Welcome to qnawire.
In this problem, three blocks of masses of 1.5 kg, 1 kg and 0.5 kg is kept on a horizontal frictionless surface. A force of 36 Newton is applied on the last block in the given direction. So we have to find what will be the acceleration of each block. So we know that when this force will act on this system, then entire system will move in forward direction since there will be no resisting force as there is no friction. So we can assume that three blocks to be a single blocks of mass sum of the individual masses. So what is the mass? m1 plus m2 plus m3, which will be equals to 1.5 plus 1 plus 0.5, that will give 3 kg. So on 3 kg block, if 36 Newton force is applied, then what will be the acceleration? So acceleration will be equals to force divided by mass. So total force is 36 Newton and total mass is 3 kg. Therefore, net acceleration of each block will be 12 meter per second square. Therefore, acceleration of each block is 12 meter per second square. Now in second part, we have to find net force acting on each block. So we know that from Newton's second law, net force is equals to, from Newton's second law, net force is equals to mass into acceleration. From Newton's second law. So net force acting on block 1, we know that acceleration is same for each block. Therefore, only the masses are varying. So because of the varying mass, the net force will change for each block. So net force for block 1 will be equals to mass of block 1 into acceleration. So mass of block 1 is 1.5 kg multiplied by acceleration is 12. So this will give 18 Newton. Net force acting on the second block will be equals to m2 into a, and m2 is 1.5 and acceleration is m2 is 1. So 1 into 12, which will be 12 Newton. Net force acting on the third block will be equals to m3 multiplied by a, and m3 is 0.5 kg. So 0.5 multiplied by 12 will give 6 Newton. So these are the three forces that will be acting on each blocks, and these are the net forces actually. In third part, we have to find the pushing force between the blocks. So let us look at the diagram, and we have to assume that the block 1 is pushing the block 2 with force N2. Then the block 2 will also push the block 1 with the same force N2. And let the forces between the block M2 and M3 is N3. Then from Newton's third law, it will also push the block N2 with the same force N3 in opposite direction. So these are the action and reaction pairs. This N2 is reaction pair of N2, and this N3 is reaction pair of this N3. Therefore, now we can draw free body diagram for each of the blocks. So if we draw free body diagram for first block, then from left hand side 36 Newton force is acting, and from right hand side N2 force is acting. And for the second block, from left hand side N2 force is acting, and from right hand side N3 force is acting. Alright, and if we do the same for third block, then on third block only one force N3 will be acting. So this is block 1, this is block 2, and this one is block 3. So basically we have to find the value of N2 and N3. We know that net force in case of 1 is, just we have calculated, it is 18 Newton, and net force in case of 2, F net 2 is equals to 12 Newton. Net force in third case is 6 Newton. So what we can write here, net force, how we can write net force for first case? So net force will be, since the motion is in forward direction, therefore we will consider the forward direction to be positive. So net force will be 36 minus N2, that will be equals to 18. In second case, in forward direction, if we consider the positive, so N2 minus N3 will be equals to 12, and in third case N3 will be equals to 6. So we have got one of the pairs or pushing force of N2 on N3. Now if we put the value of N3 in second equation, so N2 will be equals to 12 plus N3, so 12 plus 6 will give 18. Therefore N2 is equals to 18. So we have got the pushing force between the blocks first and second also. So therefore what is the in C part, it was asked that what is the pushing force in each block. So pushing force between 1 and 2 is 18 Newton, and pushing force between 2 and 3 is 6 Newton. So this is the answer for this problem.